On page 4, the section B, first one, we learn how to classify all the different type of the numbers. And there's all different type of the numbers in the world. Let's start with the beginning, complex. Okay, the complex number is any number with the format a plus bi. And the I is an imaginary number. So that means when we have a real number part plus a number times by imaginary number, what we call this kind of number is complex number. And if this number b is equal to 0, that means there's no imaginary number anymore. And we only left the real number a. That's why when b equal to 0, we call that numbers a real number. Okay, and if the a equal to 0, that means we only have something times by I. So that's an imaginary number. That's why when a is a 0, we call these numbers is pure imaginary number. And now let's talk about the real number. For the real number, same thing. Let's start with really beginning. When we have a number, counting number, like 1, 2, 3, keep going, all those numbers, we call those numbers a natural number. We call those numbers a natural number. And if we have all the natural numbers, but plus one more number, 0, and we will call those numbers a whole number. And after that, if we have all these numbers, 0, 1, 2, 3, keep going. We have all the whole numbers and plus something negative, like -1, -2, -3, keep going. And we will call those numbers a integer. And if we have all the integers and plus some fractions, and also plus some decimal, and we will call those numbers a rational number. But not all the decimals are rational. Any number, if we can rewrite as a fractions, and what we call this number a rational number. For example, 1/3. That's a fraction, so it's a rational number. But if you rewrite this number to decimal, that would be 0.333, keep going, repeat. So we will call all the repeating decimals are rational numbers. And then if we have rational numbers, that means we will have irrational number. What's an irrational number? Irrational number is number you cannot write to a fractions. For example, 0.235, keep going forever, never stop, never repeat. We will call this kind of number is rational number. Also, pi. Pi is an irrational number because pi is equal to 3.1415926. Keep going. Never stop, never repeat. That's why pi is an irrational number. And also, if it's a radical, it's not perfect square. We also call these numbers irrational. And all the rational plus irrational, we call those numbers are real numbers. Okay? And that's what we're going to classify the different type of the numbers. Now, example. Look at the classwork on your paper. First, 12. 12 is a counting number, so which is natural number. If it's a natural number, that means also will be whole number, also will be integer, also will be rational, and will be real, and will be complex. So actually you need to write down all those. So it will be natural number, and the whole number, and the integer, and the rational, and the irrational, and the natural, and the real number, and a complex number. That's all the way you need to do for 12. And for b, that's a square root of pi. So as long as pi is irrational, so that means this number is irrational. If it's irrational number, that means also is real number. If it's a real number, that means also is complex number. Okay, let's do a couple more examples. 12 over 25, that's a fraction. Any fractions we can make be rational. That's why this is a rational number. If it's irrational, also will be real, also will be complex. Okay, let's do one more. 0.121121112. This decimal is not repeating decimal. Also, it's a decimal. Never you can find the terminal number digits. That's why we call these numbers is irrational. If it's irrational, that also will be real, also will be complex. And that's how you find how to classify all those numbers for the rest of problems. And let's see one more, last one. You have a negative number inside. So we cannot have a negative inside if this root is even number, because any number with even power should be positive. That's why we cannot have a negative inside. But if we do have a negative, that means you should have an I outside, because that's an imaginary number. That's why we call this is a pure imaginary number. And this one doesn't have the whole number sections, the real number sections. That's why we only call this is pure imaginary, and also will be complex. That's how you classify the numbers. And for the page 4, page 5, first one, I need you to know all this. That's all the 5 different ways to describe a solution of the function. First one, x equal to a number. It's a root of the function. The define a root of the function is what's the x value when the function equal to 0. So when you make the function equal to 0, and then you solve for x, that's how we find the root of the function. And if x equal to a, it's a root of this function. That means x equal to this number also is a 0 of this function, because that's a value when the function equal to 0. And also you can say that's a solution of this function. And if it's a 0, that means the graph will be passing through this point on the x-axis. That's why you're also able to call this is x-intercept. And also, if a is one of the solution, that means x minus that number is a factor of these functions. Okay, and that's an example of how you describe those answers for each of the problem. And then for the page 5, that's how we solve the polynomial function of a degree 2. So actually, which is a quadratic function. So every time when you have a quadratic function, the first thing you need to do is factor. Okay, that's why we always need to factor first. And look at the part A. This is a quadratic function. If we solve for x, so we set this function equal to 0. We set this function equal to 0. And then by factor, first you should look at if there any greatest common factor. If no, let's start to doing AC factor. We're doing coefficient of this term multiplied by this constant number, which will be negative 15. And then we factor this number to 3 and 5. And I try to add these two numbers, make it equal to this middle term's negative 2. So that makes the bigger number be negative. And all over leading coefficient x. For this question, leading coefficient is 1. So just be 1x. And then you're able to factor x plus 3. You just bring down whatever you have. And that will be x minus 5. That's how you factor. And then when this whole thing equal to 0, you make each of them equal to 0. So x from here will be negative 3 because you move 3 over. And from here, that will be 5. That's how you solve this. Okay, let's try some example. So f of x is 2x squared plus x minus 15. For this question, first we set this equal to 0. And then let's do coefficient times this number, which will be negative 30. And we factor negative 30 to 5 and 6. I need a positive 1. So that means this will be negative 5. This will be positive 6. And we always divide by leading coefficient times x. The leading coefficient of this problem is 2. So it will be 2x, 2x. And can you simplify these fractions? If no, bring down. And we can simplify these fractions. And we can divide by 2 from top and the bottom, make it be 3 over x. And that's the one you need to bring down. So it will be x plus 3. And then you set this equal to 0. So from here, x will be 5 over 2. From here, x will be negative 2. That's how you solve this by factoring. Okay, let's do one more. F of x is 3x squared. I have a 6 here. Okay, minus 7x minus 6. For this one, first set this equal to 0. And then we can do first number times last number, which will be negative 18. And we factor negative 18 to 2 and 9. I need to add these two numbers equal to negative 7. So bigger number need to be negative. And then divide by the leading coefficient is 3x. I can highlight this number, where this number came from. So this 3 come from here. And for this problem, this 2 come from here. And for this one, that's 1 from here. Okay. Let's finish this one. There's no way to simplify this, so bring down. And then you're able to simplify this one to negative 3 over x. So that's the one you bring down. And equal to 0. So let's solve it. From here, we move 2 over, divided by 3. That will be negative 2 over 3. From here, that will be just 3. That's how you solve for x by factoring. And there's one more question like this. If we have 2x squared plus 8x, for example, like this. When we set this equal to 0, the first step, find the least common denominator. We do have a common denominator not a common denominator. The greatest common factor. We do have a greatest common factor. First, 2a. We do have a 2. And then x squared, we have x from both of them. So you need to factor this 2x out. And then you will left x plus 4. Now you just make each of them equal to 0. When this equal to 0, x is 0. When this equal to 0, x is negative 4. And let's do one more. If we have x squared minus 4, we solve for x. There's two ways. First way, we set this equal to 0 and factor this. First, you should recognize that's the difference of perfect square formula, which will be x plus 2 times x minus 2. And x will be positive 2 and negative 2. Second way, we move the 4 over. So x squared will equal to 4. And then you just square root on both sides. When you square root, you should have a positive and negative. And the square root of 4 is 2. That's how you're able to get the answer. That's how you solve the quadratic by factoring. But it's not all the time you're able to factor the question. Okay, now let's see some question. If you cannot factor, how we're going to do? Actually, we're going to do the quadratic formula. So that's a formula you should use for the quadratic functions. But look at here, there's a square root. We just said you cannot have a negative number inside of the square root. That's why the inside, b squared minus 4ac, it doesn't matter. So we call this term is discriminant. And we're using this term to determine how many solutions you have and what kind of solution you have. If the b squared minus 4ac is a positive number, you should have two real solutions because one is a plus, one is a minus. But if this term equal to 0, square root of 0 equal to 0. So plus or minus actually doesn't matter anymore. That's why you only have a one real solution. Third one, if this term is a negative, you cannot have a negative inside of the square root. That's why you should know answer will be imaginary number because square root of negative 1 is equal to I. Square root of negative 1 is equal to I. That's why you know your answer will be imaginary numbers, but not real solutions. Okay, so look at the first one, part A. We're using the discriminant to determine how many solutions we have first. So first, when you get these functions, you should look at which number is A, which number is B, which number is C. So that's a A, that's a B, that's a C. And the discriminant is a b squared minus 4ac. So it will be 23 squared minus 4 times 40 times negative 30. And when you're using a calculator, this will be 5,329. And this is a positive number. When you have a positive number, that means you should have two real solutions. Okay, so we just plug into the quadratic formula. So x is negative b, and the b is 23. So it'll be negative 23 plus or minus square root of this number all over 2 times a. A is 40, so it'll be 80. And then now we just need to simplify. Square root of 5,329, that's a 73. So it'll be negative 23 plus or minus 73 all over 80. One is a plus, one minus, so you just need to solve them individually. When we have a plus, negative 23 plus 73, which will be 50 over 80. And when you simplify, that will be 5 over 8. When we have a subtraction, and the negative 23 subtract 73, that will be negative 96. And then same thing, when you simplify this fraction, that will be negative 6 over 5. So that's the two solutions you have. And you can see they are all real numbers. That's how you solve the quadratic function. Okay, let's do one more. Okay, let's do C. C is f of x equal to x squared minus 5x minus 2. Okay. First, let's find the discriminant. That helps you determine what kind of solution you have. Okay. So b squared minus 4ac for this one will be negative 5 squared. Remember, you have to use a parenthesis closest number when you type to the calculator. Minus 4 times 1 times negative 2. And which will be a positive 33. And you should know answer going to be two solutions. Now let's solve it. So negative b. B is a negative 5. So negative b will tend to positive 5. So 5 plus or minus square root of b squared minus 4ac. And you already did that, which is 33. All over 2. And the 33 is now perfect square. So you just leave there. Don't change to decimal. Just keep your square root. And that's it. That's your final answer. So you should have two real numbers. And also they are rational numbers. they are irrational. They are irrational because the square root. And let's do one more for D. Okay, that's a part D. Same thing. Let's determine what kind of solution we're going to have. So B squared minus 4AC. And which is B is 1 minus 4 times 2 times 2. So it would be 1 minus 16, which give you negative 15. When you have a negative discriminant, you should know answer will be imaginary number. Okay, so let's do quadratic formula also. Will be negative B, that will be negative 1, plus minus square root of negative 15, all over 2A, so it will be 4. You cannot have a negative number inside of the square root, so you have to continue simplify. We keep the negative 1, no change. Keep the plus and minus. And then square root of negative 1, which is I. So that's why you need to put I outside. And look at inside what you left. You left 15. 15 is not perfect square. So you just keep this 15 inside of the square root. And all over 4. That's it. That will be answer for this question. That's how you solve this by using quadratic formula. That's rational solutions. That's irrational solutions. That's imaginary solution. That's the 3 different situations. And that's how you work on the homework page. What page? That's how you work on the question number 4. On page 17. You just solve the x. So you set each of this equal to 0, and then you're able to solve. If that's a linear equation, you just get x by itself. If you're able to factor, you just factor. If you are unable to factor, you just use a quadratic formula. Okay, that's how you do the question 4 on the page 17. And then make sure you know how to factor, because we had a factoring quiz over this. Just a factor. Okay, that's pretty much like this. And if you have any question, email me, let me know.